Okay, so I'll talk a little about myself first so you know who I am. So I run Founderspace. We're a global startup incubator and accelerator. We work all over the world. I was just in Asia with Jack, traveling around. We were looking at a bunch of VR companies and giving some talks. So he's a friend too. If Founderspace has been around 10 years, I'm usually traveling. So I travel a lot to a lot of different countries, and we bring a lot of entrepreneurs into Silicon Valley, and we help entrepreneurs in Silicon Valley, grow their companies and also go abroad to other markets. I am also author of 3 books. Make Elephants Fly, it's all about radical innovation, and it was published by Hachette. Surviving a Startup is all about everything you need to know to survive. I've done 3 venture-funded startups. I know how tough it is for any of you entrepreneurs out there. All my experience is in that book, plus the experience of lots of other people that I know here. And then the 5 Forces is about new technologies, in particular AI. And how that's really changing society and changing the world. And that just came out. So now I'm going to give you some of the things that fascinate me about generative AI. And I'm going to go inside those and just share my thoughts, and then we can talk about it. So we all know this, right? The major generative AI applications out there and how the models work, the large language models pulling data from the internet and the user prompt. What I was interested in is how do they train these large language models? What do they do? For those of you who are ML engineers, you know this, but for those of you who aren't, it's interesting. What they do is their goal is to have the ML model understand the sentence. So for example, the sentence is, a dog buried a blank in the yard. So they give it training data with the sentence and a word removed from the sentence. And the theory is this: if the AI can successfully predict what word should go in that sentence, then it has an understanding of the sentence. So in this case, a lot of things could be buried in the yard. You could bury a truck in the yard, but is a dog going to bury a truck in the yard? Probably not. A toy could be buried in the yard. Yes, a dog could bury a toy, but is that the most likely answer? No. Probably the most likely answer for most of us humans is to bury a bone in the yard. And so how do they come to this conclusion? How do the AI models work? And as it was explained to me, what they do is they look at the relationship between words, and it's all math, right? So there's a relationship between all these words, and they map it out as vectors in multi-dimensional space. And the more words there are, the more dimensions you have. So unless, and you're nodding, that's good, I'm getting this right. So unless you really understand math at a deep level, you wouldn't understand this. But the fascinating thing is they have these groups, these clusters of words, and they figured out that the distance between words, the closer they are together in this multi-dimensional space, the more likely it is a match. And what they do is, you notice when you're on ChatGPT and you type in a prompt, so you ask it a question, and then it comes up with an answer. It predicts 1 word at a time. So it doesn't actually know what's coming next, but it's always looking for the most likely thing based on not just your prompt, but all the words it has generated up to the next word. So it's a iterative process where they're literally feeding that data back in, and the more words they put down there, the more they're feeding back in. And that's, in a nutshell, how it works. Now, multimodal AI, everybody's talking about multimodal AI as the next big thing. And what fascinates me about this is we already know it does text really well. We're all using that. We know audio. There's lots of AI that creates music out there and other audio. Vision, images, Midjourney, Dolly, all that stuff. They're also working on other modes. Like each one of these types of input, the data, requires a different algorithm and training data, a different way of going about understanding it. And they're working on that for chemistry right now. They're working on that for predicting climate change. For basically everything you could imagine, they can be developing specific models for that and doing it. Now, where we're headed is that how do you combine these to get multimodal outputs that are really interesting? And I'm going to go to one simple example for you. So the simple example is when you use, all of us have used Midjourney, DALL-E, all those applications, that is a multimodal. So because it's multimodal, because you are typing in text and then you're getting out an image. So two different modes. And the really interesting thing is, so if you have an image of a cat like we have here, this brown and white cat, sitting on the floor, if you have an image of the cat and you literally, what it does is there's lots of images of the cat on the internet, so it can get all that data. Then there's lots of text related to those images. So it can pretty much understand, if you have this text near this image, this is a cat, right? The word is related to this type of image. Now, but what it does, when you type in, I want you to generate a cat on Midjourney, it doesn't just give you the cat from the internet, because that would just be search. It would just be pulling up a cat from the internet. What it does is it generates a new image of the cat that never existed before. It creates a new image. So what I want to explain to you is, how does it do this? How do they create a new image of a cat that didn't exist? What they do is really amazing. They do something called stable diffusion. And in very simple terms, stable diffusion is where you take that image of the cat from the internet, and then you start to add, you start to diffuse it, blur it, add random pixels to it. And you do go through this process, and it's called encoding. So they're encoding it by blurring it out. And you're like, why would you blur out an image to create another image? Well, this is why. When you request a cat from Midjourney, or DALL-E, or any of these image generation software, what it does next is it doesn't start with the blurred image that they made. It starts with random pixels, random blurry, noisy pixels. And then it applies the encoding method in reverse, so it decodes it. So it's decoding this cat from random pixels, and what it's getting out is a cat that is similar but different. That is how, when you go to Midjourney and you say new variation, it can sort of endlessly create more variations because they're just starting with new sets of random pixels. And that's the magic behind what we see, and we're so amazed by. So there's another question, another thing that fascinates me. I ask myself these questions, and then I try to teach myself, and I figure if I can learn it, anybody can learn it. So another thing that fascinates me is, are bigger models better? See, we've seen exponential increases when models get bigger. So we started off with GPT-1, GPT-2, GPT-3. They're getting exponentially more powerful. Will this continue forever? Well, not necessarily. It's not, having a lot of data is great, but after a certain point, you have enough data, it doesn't necessarily mean you're going to get better results. And what we're also seeing is that these bigger models require huge amounts of computing power, huge amounts of memory. That means a lot of money to run them. OpenAI is spending enormous, that's why they had to raise $10 billion, right, to keep OpenAI running. OpenAI can afford this. Google can afford this. Facebook can afford this. Can we afford it? No. We have to use their platforms in order to be able to afford it. But that may be changing. And this is the really exciting part. So right now, Microsoft, of all companies, just released an open source project called Orca. Have people heard of Orca? Well, you know everything. But no, has anybody else? Well, Orca, yeah, few of you have. Let me explain. And you should go home and Google this after my talk. So Orca is pretty amazing. What Orca is, it's an open source model, but it's 1/7 the size of the public ChatGPT. 1/7. Yet, it performs as well. And this is GPT 3.5. GPT-4, which you would pay for, is a little better, but Orca could potentially get as good as that. Now, how is Orca able to do this with a much smaller model? Well, they did it very cleverly. So Orca will actually leverage the large language model of ChatGPT. So instead of doing exactly what ChatGPT does, instead it goes to the API of ChatGPT and it asks it questions. And it doesn't just ask it questions to get the answers. It asks it questions to learn how it got the answers, the logic behind getting the answers. Now, this is the fascinating part. So it will ask it a question, and then it will ask it to explain how it came up with that question. And it will even do things like explain to me as if I were a 5-year-old. In very simple, step-by-step terms, your logic, it's asking ChatGPT to do this, of how you got this answer. And it learns from the explanations instead of just from the raw data. And they've found that by learning from other language models that are bigger and how they think and how their logic, you can actually create a much smaller model that performs just as well. Now, Google is about to release Gecko. And Gecko is basically supposed to be small enough to run on a smartphone, a small enough model to run on your phone. And these models can run offline, not just online. So what does that mean for us in this room who are entrepreneurs and developers and things like that? Well, it means something very exciting. It means that we could now run Orca, you can run it on a powerful laptop. So you could literally run it on a laptop if you're a developer, right? You don't have to pay OpenAI. You don't have to be reliant on their platform anymore. This is really disruptive, right? You can run it on your laptop, and you could run it offline. You could have all the data there. You don't have to have it in the cloud, so you don't have to pay that cost. If you're building robots or IoT devices, you know, you could literally be running these models, especially as they get smaller and smaller and are still powerful, on the device, in the robot, in the IoT device. That opens up a whole range of opportunities for people who are entrepreneurial. And this is the exciting thing. So I wanted to bring that to your attention. Can you copyright AI-generated content? So this is another thing I was like, can I copyright this, right? Well, the answer is no. So a lot of people are using it for their businesses, for books, for writing articles. Under US copyright law, it says very specifically, you cannot copyright anything created by a non-human. So a machine that creates something you do not own the copyright to. That is the law. May change, but that is the law. The other thing that's really interesting is not only can you not copyright it, but there's actually a way around it. And so this is a tip for you. Some people say, well, if I created the prompt, it's not just created by a machine, it's actually created by my input. So could I copyright it then? Probably not, okay? Probably a prompt is not enough. It's still a gray area. But if you modify it, and you modify it significantly, then you can copyright it. So let's say you ask it to write an article for you that you want to get published. If you made enough changes to the article, you could argue, and it would have to be in court if somebody brought it up, you could argue in court, oh, but all these changes, that's what I'm copyrighting. I'm copyrighting it's a new work of art based on my work. And there are artists out there who use found materials, who use other materials and put them together. Music has had this thing with sampling, So there's some precedent for this. We haven't worked it all through. But you have to be careful. You have to be careful. I know because the big publishers, I've talked to the big publishers, I get my books published, right? And I'm like, can I use AI on my next book? And they're like, if you use generative AI on your next book, we will not publish it. So if any of you are writing a book out there using generative AI, don't tell your publisher. Because once you do, they can't publish it legally. They will not go there. So that's some things for you to think about. And my next thing that fascinates me is intelligent agents. So this is where everything is headed. I mean, this is another huge opportunity that's out there. So AutoGPT, do most of you know about AutoGPT? You probably do. AutoGPT is out there, right? It's very simple. It's a very simple piece of code. It's like a do-while loop, a very simple loop that keeps going back to the large language model and breaks it down into steps and flushes it out. But so what it does is you can ask it to do more complex tasks. solve more complex things and sequential things. So you could say, for example, I'm going on a vacation, help me plan out my vacation. And then it would go to the large language model, whether it's Google Bard or, ChatGPT, and it would basically ask it, how do you plan out a vacation? What are the steps? Then it would take each of those steps. Oh, first you have to figure out where you're going. Then you have to, book a flight. Then you have to make hotel reservations, and what do you want to see, and all these different things. It's actually complex, planning out a vacation, especially if you have many different stops along the way. And it would go through these steps and iteratively break them down into smaller and smaller steps until it feels like it can give you a whole plan for what to do. AutoGPT can do this. It's not very good yet, right? But where we're going in the future are really intelligent agents. Really intelligent agents that will literally not only be able to plan everything out for you, but actually be able to execute on it. So like you could actually say, okay, I'm going to Rome, I'm in San Francisco, can you book me the flight? Oh, and can you make me a hotel reservation? And the AI in the future will go out, talk to other applications through their APIs, actually do all those tasks for you, saving you an enormous amount of time, like having a real travel agent, interacting with you like a travel agent would, and all the different details. What is really interesting is that once these AI come into the marketplace, and they will be coming, a lot of people get very rich making some of these. They will become, because they're so useful. You can imagine, it's not just for travel. It can be for planning out a wedding, that's a lot of work. It can be for doing business processes, in negotiating deals. All sorts of different things will be done by intelligent agents in the future. The interesting piece of this is that as an intelligent agent goes out for you and does this, we as human beings will become more and more reliant on them. And I'll tell you why. Because they're so good, and because they will start to know us so well. So you can imagine, let's go back to the example of travel. If I travel all the time, and I have an intelligent agent that I work with over a period of time, that intelligent agent will begin to learn not just how to book hotels and how to plan trips, but it will learn what I like. How much money I like to spend on hotels, what type of food I like to eat, where I like to go on vacation. And there will come a point in the future, and it will be probably within our lifetime, where we will literally go to these intelligent agents and we will say, instead of monitoring every step, we'll just say, plan my vacation. Like literally plan my vacation. I'm cool with wherever you pick. Like, my budget, what I like to do, plan it. It'll come up with the whole thing. And we'll say, oh, that's awesome. Or change this, and then you do it. That's where we're going. Same in business. So it's going to be revolutionary. A lot of our jobs will be what I call human-computer symbiosis. And that will apply to our personal lives and our work. So we will be inextricably tied to these AI. Like AI will be in literally every facet of our life, helping us get stuff done and enjoy life more and collaborate with each other. And this is why I'm such a big believer in AI. This is why I think it's really poised to change everything we do beyond, and he's clapping, all right. So, my last slide here. A lot of people, another question that I ask myself, and I wanted to know the answer of, is will AI become sentient? And sentience is interesting. So, in order to be sentient, you first have to be conscious. So consciousness comes first, sentience comes later. Consciousness, as we know, is our ability to be conscious, to act at free will, understand the world around us. Sentience is our ability to not only be conscious but feel, get input, and all the and feel sensations and emotions and things like that. So remember, I gave you the example earlier about the AI that understands a sentence, right? The AI understands us. It understood that dog is the word that should be in that sentence. The bone, I mean. The dog buried the bone in the yard, right? It understood that at a certain level. But we have to think about it. Did AI understand the sentence in the way we understood the sentence? Like when we think of a dog and a bone, like when I think of a dog, I have all my memories of a dog, all my feelings and emotions of a dog, the experience of being with the dog. Did the AI ever have that experience of being with a dog? No, right? What it understood, it's all math. It understood the relationship between the word dog, the word bone, the word yard, all these different things in this huge context that we have created for it because we humans gave it all that data. And then it plugged it into this math equation and came up with an answer. So somebody at Google, one of the engineers we all heard about, thought the AI was conscious, right? That it actually understood. What you have to understand is that it all depends how you define consciousness and sentience. So in the future, AI will be able, just like it can understand a human sentence and respond to us as if it were human, it will start to, the more data we give it from ourselves, from the world around us, the more AI has sensors, sensory input data, vision data, audio data. Robots are going to be everywhere. They're going to be gathering massive amounts of data. So the future of AI will be that these AIs will be able to understand the world. And they will be able to communicate with us as if they were human. Because we won't be able to tell talking to an AI, and we're already at the point with some of these, where the Turing test is very blurry right now. Like a lot of these AIs, ChatGPT included, could pass the Turing test. Theoretically, it depends how you define the Turing test, and how strict you are. But it definitely, within the next few years, you are going to be chatting with AIs, and you're not going to be able to know it's an AI. So pass the Turing test. You will be able to be talking, interacting, having relationships with AIs, and they will be able to perfectly simulate how we act, down to our emotions. That doesn't mean the AI will have those emotions or will have any of those concepts. Just like it understands the sentence, that what a bone is in context of that sentence, it will understand the world in the same way, but it will not feel. It will not know what it's like to hug and love a dog the way we do. We are biological creatures. We are very different. So the answer is AI will be conscious and will act in the world like a conscious being, but its consciousness will be fundamentally different from our own. And we will never, we will be fooled. Many, many people in the future will believe that the AI has emotions like them, that the AI might even care for them, that the AI sees the world as they do, because it will be so good at simulating this, at acting like it does, when internally it is very, very different. So that concludes my talk. Thank you very much. And if you have any questions,
yeah, maybe, I know we want to get to this next part, so
yeah.
If we can launch right in, and we're a little bit behind time, so I want to make up.
Okay,
there's burning questions. Burning questions. Okay, I know it's probably a ton. That was covered an immense amount of material. Okay, we're going to keep the questions really short, one-sentence questions, and then hopefully short answers.
That's the hard part.
So you gave the example of intelligent agents booking flights, hotels and all, but in real life they may face like many ambiguous questions from our side. Like suppose medical data, a patient can have multiple symptoms which can correspond to multiple diseases. So in those type of complex cases, how will these function like?
Oh, how can the AI function with so we all know that AIs hallucinate, right? They get things wrong. That will continue to happen. We will be correcting that, of course. We'll be doing it a lot of times through reinforced learning, which is where we actually tell it that, oh, you got this wrong. And they do this, like OpenAI and ChatGPT. We think it just learned from unstructured data. Well, that's true up until a point. And then they had a lot of people go in there and correct things that were wrong. And they still can't get everything that's wrong. So for medical data, this is why there's a lot of liability here. This is why when you go to Google Bard, which I did, and start asking it medical questions, it just drops out. It says, I can't answer those because they don't want to get sued. So it's going to be a while. In what we're going to do, this is what we're going to see. Sorry for the long answer, but it is a complex question, right? Yeah. What we're going to see is that these AIs for medical are always going to say consult a doctor. So the AI is going to take the first pass, and then to get the liability off their plate, talk to the doctor. Yeah.
And one thing I want to say, we're going to be producing with the team here at AIFI that's growing and our partnerships that you'll learn more about. We will be producing a lot more events and hopefully have Steve and others and be able to spend a long time on each person. So some more event formats coming up, and this is not quite just a teaser because we are going deep and we are covering all aspects, but we also want to go even deeper. One more here and then one there.
I actually got a very complex question, but I'll just ask you if there's runs out of time, we could discuss later. So I'm really fancy the idea of the intelligent agent, but I'm curious about your thoughts on the future of human, because in that case, human seems to be like less and less smart, and like we will now train our neural works very much. So in that case, like, what do you think with our future?
Yeah, that's a real challenge for us. Because, literally, what you're saying is one of the big challenges we'll face. So we're going to face it at a certain point in time. AI will literally be able to do almost any job you can imagine better than us. I mean, there were people just a few years ago who said, AI can never create art. That argument has sort of gone away, right? Because the artwork it creates is absolutely stunning, right? And it does it in seconds instead of weeks or years. So as human beings, maybe CRISPR will save us. We'll upgrade ourselves, right? Just like computers, because we have the source code to life now. So we can restructure our genes potentially and make ourselves smarter. But at a certain point, AI will always outdo us. The other option is, implants. Right, literally merging with our machines. So brain-computer interfaces, actually getting, Elon Musk wants to stick a chip in your head. I don't know if I trust him, but to be the one, or Mark Zuckerberg wants to do it. I don't trust him either. But we could go down that path. And literally, but it's a very complex path, right, to actually interface between the brain. But that will happen at some point. So we're already merging with our machines. So that's why I talked about human-computer symbiosis. We are literally going to, in the next decade, all of us are going to be doing our jobs with AI. Most of everybody in this room, because we're in San Francisco, but around the world. And that's just going to accelerate. So that's my shortest answer I can give.
And one more here, and then we're going to get on to that next piece that you want to talk about.
Yeah.
A question on the sentience and the challenge.
Yeah.
What makes you think human beings are not giant autocompletes and machine learning systems that are learning through data sets of experience and lived experience and learned experience?
That is a great point. We are pattern matching machines. That's how our brains are built, just like was said previously. AI is all it is pattern matching. We learn through our own experiences. The difference is we're biological. They're created out of silicon and other materials. This comes back, it's a very philosophical question, right? So if you believe in a soul, if you believe there's something beyond the material world, then your answer would be no, we have a soul, right? You can't argue with that. If you believe we are material beings, then yes, we are machines, right? We're just biological machines. That is my belief, right? I believe we are biological machines. We are not necessarily that different as we'd like to think. Like we used to think animals were very different from us. Animal consciousness was very different from us, right? And we still eat animals. But we have learned to discover that animals have feelings, animals perceive the world in a very similar way that we do. Could machines do all those things? The answer is yes. Yes, we could build. I'm not saying we would ever understand their consciousness. It would be different from ours, but they may evolve to the point where for all intents and purposes, they are conscious. Okay, that's my answer.
Okay.